All right, good morning or afternoon, people. Last one of this week. I know it's been a long week with a lot of stuff going back through factoring, going through synthetic, and solving yesterday. So we're getting to our last thing. If I'm not giving you a term, we're going to talk about the rational root theorem, which is nice. So let's look at a few things, kind of narrowing down some things, kind of a quick review. So given a factored polynomial, how can we find the solutions, the zeros, the roots, whatever you want to call them, of the polynomial? So if I have this polynomial, how can I find my solutions? So remember, what we're going to do is we're going to take each part and set it equal to 0. And then we solve. So we set each factor that has an x equal to 0 and solve. So set each factor that has an x equal to 0 and solve. If it doesn't have an x, it's just a constant, so it's not going to be a solution anyway. That'll come into play with our GCFs, sorry. And then now I just solve for x. So x equals 3 minus 1, so 2x equals negative 1, so x equals negative 1/2, and x equals negative 8. So you get your 3 solutions in this case because I got 3 parentheses, so we're good to go. Running through a couple of quick ones, kind of a quick review. This one's already in factored form, so you set each part equal to 0. So x equals negative 2, x equals 5, x equals 3, negative 4, and then 5/2. You can just list them, nice and simple, switching the signs when you move it to the other side. Not so simple here. So we're going to factor this one. I have 4 terms, so we're going to start here, kind of looking at it. I have a GCF of 3. So if I take a 3 out, that's going to be a 5x to the third plus 5x squared minus x minus 1. So now I can group it. I have 4 terms. This is the oddball with that minus sign, so we talked about that. So 5x leaves me with an x plus 1. If I take out a negative 1, that's going to switch the sign. So remember, if I have that negative, it switches that back sign, so that's what allows me to get these guys. So keep it consistent the way I taught it. So x plus 1 is going to be your first set. 5x minus 1 is left over. Then bring down your 3. So now you set each part that doesn't have a 0 equal. I forgot the square. That's my bad. So I got x plus 1 equals 0. I got a 5x squared minus 1 equals 0. So x equals 1. That one's simple. Subtract 1. So 5x squared equals negative 1. Divide by 5. This is add 1. So x squared equals 1/5. So now I can take the square root of both sides. So remember, when you take the square root, it's plus or minus the square root of 1/5, and we'll just leave it like that. So I got my 3 solutions there. Cool. So grouping, keep things straight. Make sure you're looking through it. This is what we talked about yesterday as a good review. So solving. Here I got a difference of squares. 4, x squared, and 9 are all perfect squares. So I can rewrite that as 2x squared, 3 squared. So remember, it's 2x plus 3, 2x minus 3. So set each part equal to 0. So 2x equals negative 3, so x equals negative 3/2. 2x equals positive 3, so x equals positive 3/2. This is also 1. If you only have one term up top, you could solve it. So 4x squared, if I move the 9 to the other side, divide by 4, so x squared equals 9/4. When I take the square root of that, remember it's plus or minus. Square root of 9 is 3, square root of 4 is 2. So you still get the same answer if you do it that way. I know I'm going quick through these review problems, but it's a good thing to go through these one more time. And then the last one is just a typical normal factoring. No GCF. So build it. 5 times 2 is 10 to get 7. So what factors to 10? Add to give you 7. We got a 5 and a 2. So x plus 5, x plus 2. Don't forget, we got a 2 there, so we have to divide them by 2. So x plus 5/2, x plus 1. So 2x plus 5 and x plus 1. So x can equal negative 5 halves, x can equal negative 1. Cool. So if you need to go back through factoring, grouping, setting each part equal to 0, difference of squares, please pause it, please back up, go back through it before we move on. All right. Give you a second to pause it. So now, a couple definitions here. The fundamental theorem of algebra. The degree of the function is equal to the total number of solutions as long as it duplicates are counted as separate answers. So whatever the degree is will tell you how many solutions you will have. We'll talk about multiplicity later on. But if you repeat duplicates, you will have that amount of solutions. So the rational root theorem, or you'll hear it RRT, just abbreviating, is given a polynomial with integer coefficients. So integer coefficients are always positive, negative, whole numbers. So no fractions really. Every zero of the polynomial can be written in the form of P over Q. So that's important. You'll hear me say, what's your P's, what's your Q's, list them out. So P is a factor of the constant term. So that remembers the term without an X. Q is the factor is a factor of the leading coefficient. Remember, that's the number in front with the highest degree. So when it's in order, it's the highest degree X term. It's the one that's sitting there. So sometimes factoring the quadratic formula won't work at first, and the problem won't give you a 0 or factor to start with, so you need another way to do it. That's why we have the rational root theorem. All right. So some important notes of the rational root theorem. So you can pause this, read through it. I'm not going to read through it. So important things you need to know. So first one, the rational root theorem gives us a list of possible zeros. P-O-S-S-I-B-L-E. It doesn't give you a list of all the zeros. It gives you a list of all of the possible zeros. So what could happen? Second thing, most of the numbers in the list will not be a 0. So most won't work. The numbers won't be a 0. So once again, most of the numbers in the list will not be a 0. Lastly, we can check which are zeros by using synthetic. So check with synthetic. I'm going to show you a quick way. I'll talk about it using a calculator to kind of help narrow down the playing field. All right, so let's look at the rational root theorem. So list all of the possible. So I'm not solving it. I'm just listing all of the possible roots. So with this is always our P over Q. All right, so in this case, P is my last number. So P is 7. Q is 4. Okay. So let's do this. Watch. If you list all the factors of 7, it's just 1 and 7. If you list all the factors of 4, it's 1, 2, and 4. That's every number that can get multiplied into it. So all your possible zeros, I got plus or minus. All right, 1 over 1, so 1, 1 over 2, 1 over 4. Now I'm going to go to the 7, so plus or minus 7 over 1, plus or minus 7 over 2, plus or minus 7 over 4. And you got all of your possible zeros here you're listing. So you're taking all of the top ones and putting them over all of the bottom ones. All right, B. I got my P is 10. It's my last number here. Whatever. Q is 2. So now my P over Q, I'm going to list all of my factors. So all my factors of 10 are 1, 2, 5, and 10. All my factors of 2 are just 1 and 2. So we start listing them. So 1 over 1 1 over 2, 2 over 1, which is just 2. I don't need to write over 1. 2 over 2, which is just 1. So I'm good there. Excuse me, I got the hiccups. So then we go to the next one, 5 over 1. Then I got 5 over 2. I haven't written that one down. 10 over 1. And then 10 over 2 is 5. I already have that there. So here's all my possible zeros. Cool? All right. C, listen to all these. So my P is the last number without a 0, or without an X, so it's 4. Q is my first term, which is 5. So 1, 2, and 4. 5 is just 1 and 5. So when I write these down, 1 over 1 is 1. 1 over 5. 2 over 1. 2 over 5. 4 over 1. And 4 over 5. All right? So on and so forth. So the last one, I'll let you do it. So my P here is 12. And then 5. So you can list all of those possible ones. I think we've done enough for you to list them. All right, so now let's come down here, let's apply it. So you can kind of see a couple things that work. All right, so I want to find all of the possible zeros here, and we'll go to work and show you how it works. So it doesn't group, so this, if it groups, I have 4 terms, it'll work, it'll be nice, but I know 5 and it doesn't work. So all my possible values, so I got my P is 4. My Q is 1, so all my possible values are plus or minus 1, 2, or 4. So now I'm going to check this with synthetic division. You can just pick, it's guess and check from here, to be honest. So if I try 1, I'm going to try the small one. So 1, negative 5, 4, and 4. So bring it down. 1 times 1 is 1, minus 4, 0, 0, 4. I have a remainder of 4. So that doesn't work. So I can kind of cross out the plus and go from there. Let's try negative 1. So 1, negative 5, 4, and 4. If your numbers were close, you'd probably get it. So minus 1, I got negative 6, 6. I got 10. So you can kind of see this is nowhere near it. So that one doesn't work either. So 1's not going to be an answer. Let's just keep moving. Let's try 2. So 1, negative 5, 4, and 4. 1 times 2 is 2, minus 3, so minus 6, I got minus 2, minus 4, 0, boom. So this one works. So I'm gonna go ahead and list it. So x equals 2, that works. Once I have a solution, this is gonna be my new equation that I'm gonna work with. So I have x squared minus 3x minus 2. Okay? Now I'm down to a quadratic. I can factor, I can do quadratic form, I can do whatever. So if I look at this, factors a negative 2 that give me negative 3. Doesn't factor. So if something doesn't factor, we have to use, wow, that is just horrible handwriting. The quadratic formula. I told you it's not going to go away. So x equals negative b, so 3 plus or minus the square root, b squared minus 4 times a times c all over 2a. And that's going to give you 3 plus or minus square root of 17 over 2. So my answer's here. That's a good answer. So I got x equals 2, and I have 3 plus or minus the square root of 17 over 2. So remember the fundamental theorem at the beginning. I have 1 and plus, and I have minus, so that's my 3 solution, so it checks out. This is where we're going to get to. We're going to practice this a lot today. This is on your quick check for today. So make sure we're practicing these. We're knocking them out. It is involved. We'll come back to it again on Tuesday, I guess, or Monday when we start reviewing for our quiz/test on Tuesday. So this takes practice. It's good to go. But yeah. So this one, I see my last term has an x in it, so I got to take out a GCF. So I know right here, my outside term, x is equal to 0. That's going to be one of my solutions. So I'm just going to put that on the side. That's where this comes into play. So now my P over Q equals 12 over 2. So it's plus or minus 1, 2, 3, 4, 6, 12 over plus or minus 1 and 2. So you got a whole bunch of options here. What you can do, because I'm just using this, is type that equation in the calculator and see where it crosses the x-axis. That will give you a great, easy place to start. So when I type that in, I see that it crosses at 1 just by looking at it. So I'm gonna just try that first. So 2, -7, -7, 12. If you don't have a calculator, start with the smaller numbers and work your way up to the larger numbers. That's usually what I do anyway. So 2, -5, -5, -12, 0. So perfect. So I'm gonna start with this. X equals 1's a solution. So now I have 2x squared minus 5x minus 12. Let's check it. So 12 times 2 is -24 to get me -5. Does it factor? Yeah. So -8 and 3. Remember, you gotta divide it by 2. So x minus 4, 2x plus 3. Perfect. So x equals 4 and x equals -3/2. And as you add them to your running list, so if I look up top, I have my degree of 4. So I should have 4 answers. So I have 0, I have -1, I have 4, and -3/2. Beautiful. If you want to check your work, you can take any of those, plug them back into your original equation. You should get 0 as your solution. All right. Lastly, let's take a look at this. So I have my last one so good. P over Q is 6 over 1. So plus or minus 1, 2, 3, and 6. Let's try it. Let's start with 1. So 1, -5, 5, 5, -6. So remember here, I should have 4 solutions when I'm done. So bring down the 1. 1 times 1, I'm just guessing. -4, 1, 1, 6, 6, 0. Perfect. I'm going to list that. X equals 1 is one of my answers. All right. That's going to leave me now with x cubed minus 4x squared plus x plus 6. Still doesn't work out. It's going to be the same list, which is nice. P over Q is 6 over 1. Same list. So I already tried 1. Let's try it again and see what it does. So 1, -4, 1, 6. So 1, -3, -3, -2, -2, 4. Nope. No bueno. All right, let's try -1. So bring down the 1 times -1 is -1. So -5, that's a 5, that's a 6. -6 is 0. Boom to bar. So -1 works. So I'm going to add that to my list. And now I am left with an x squared minus 5x plus 6. Does that factor 6, -5? Yes, sir. So -3, -2. So x equals 3 and x equals 2. And I see, let's zoom out a little bit. I got my 4 answers. So 3, 2, 1, and -1. So what we're doing here is we're taking our P over Q, we're getting our list, and kind of going from there. It's a guess and check. If you have a calculator, you can type it in and kind of see where it crosses the x-axis. That's the easy way to do it. And then once you get where it crosses, you can use your synthetic division, divide it out, and you should get a remainder of 0. If not, you can keep trying and guessing and checking. Start with your small numbers because they're easier to do, and build your way up to the larger numbers. And then once you get down to 3 terms, it's a quadratic. You can try to factor it. If it doesn't factor like we did in A, go back and do the quadratic formula. So I hope this helps. Take your time, walk through the practices. You got an answer key as well with that, and then take your time working through the quick check on E-class. It should tell you which ones are incorrect, so you can go back, fix those, and you can resubmit. You get up to 3 attempts to get your best grade. So I hope you have a wonderful day, and I will talk to you soon.